you all are enjoying and inculcating all the tips, all the shortcuts, all the methods that are given to your people by stalwarts from various subjects. Today, I am Sri Pranav Krishna Pitre, Principal, GSS Pre-University College, Belgavi, going to handle a session on haloalkanes and haloarenes. Haloalkanes and haloarenes is an important chapter of your organic chemistry of 12th standard. It has a weightage of almost 1 to 2 marks in your CET. Before I enter into this chapter of haloalkanes and haloarenes, I would like to tell you something regarding organic reactions. I know you all have learned lots of organic reactions since last year and this year. You will have come across many reagents, many named reactions, many different ways, and it goes very difficult for you to remember the reactions and the reagents. One best thing that you can do from today is that you can make 4 columns in your notebook. In the first column, you write what is the reaction that you are going to learn. What is the reaction that has been taught to your people? For example, Hoffman's bromamide reaction or Wood's reaction or Schwarz reaction. This should be in the first column. The second column should be with what reagents that you have used over here. Like for example, Wood's reaction, sodium in dry ether. In the third column, you write what is the product that you are getting. And in the fourth column, you write what has happened in the reaction. What is the significant change that is happening over here? For example, in Hoffman bromamide reaction, amides are getting converted to amines with 1 carbon atom less. All these things you write, as I said, in 4 columns, and every day go through these particular reactions one by one, every day. Because organic chemistry comes to only those who write it and practice. It's a volatile subject, so you need to revise it again and again. This is how you can master your organic chemistry. And reactions, believe me, you will be remembering them for a longer time if you follow this method of writing it into 4 columns and reading it every day. Today, the session that I'm going to handle is haloalkanes and haloarenes. I'm trying to cover up almost all the points from this particular chapter. Before I go ahead, once again, let me remind you that you are giving your Karnataka CET, and therefore you have to read each and every line from your textbook. No corner of your textbook should be gone unnoticed or untouched. So here we begin with our today's session, haloalkanes and haloarenes. The first question is this. The position of Br in the compound CH3CH double bond CH C Br CH3 twice. I know as soon as you read this question, you will be in a hurry to choose one of the options, but let me tell you, writing is the best thing to arrive to a correct answer because every marks matter over here. So let us see what are the options given to us and try to recall what can be the answer for this. Allyl, A is allyl, B is aryl, C is vinyl, and D is secondary. Let us recall what all these carbon atoms are. Let us see what is an allyl is. I know you will have done this in your second year chapter, but still let us look into this particular allyl. Who is an allyl carbon? An allyl carbon basically is an sp3 carbon. It's an sp3 carbon. Okay? sp3 carbon which is connected to a carbon-carbon double bond. A carbon-carbon double bond. Okay? Carbon which is connected to double bond is sp2 hybridized. The other carbon also is sp2 hybridized. Such a carbon atom to which an halogen group is connected to is sp3 hybridized carbon. Remember this. Okay? This carbon atom is allyl carbon. Let us look into our next option, that is aryl. What is an aryl group? Aryl term comes from arene. What is arene? Arene is your benzene ring. 1 hydrogen less arene is aryl. Here bromine atom is directly connected to a sp2 hybridized carbon atom of aromatic ring. Okay, this is our aryl group. What should be our vinyl group? Vinyl group is one where the carbon atom is sp2, halogen is directly connected to that, and this indirect is directly connected to another sp2 hybridized carbon atom. This group is called vinyl. This is also sp2. This is also sp2 carbon over here. What is the difference among them? This is of an open chain. And what about this? This is an aromatic ring. Remember, there's a huge difference between carbon atom sp2 of an open chain and that of an aromatic ring. Okay, so this is your vinyl. Okay, Br halogen over here is connected to an sp2 hybridized carbon atom. Aryl, Br is connected to sp2 hybridized carbon atom of a bromine ring. Bromine here in allyl is connected to sp3 hybridized carbon atom, which is of connected to carbon-carbon double bond. Let us go to the next part. That is secondary. What is a secondary carbon? You will have learned, primary carbon, secondary carbon, tertiary carbon. This carbon, let us see who is this carbon over here. This carbon atom, who is a primary carbon? This is our primary carbon. A carbon which is connected directly to only one carbon is primary. Okay, but here the Br is connected to the second carbon, which is in turn connected to two other carbons. And this happens to be our secondary carbon. This happens to be our secondary carbon. Remember this. So these are the four options. I mean, your allyl, your aryl, vinyl, and secondary. Let us see our compound belongs to which category. Which of this category? Look into over here. Most of the time, you will directly go to the answer. But the best way in organic chemistry is to write the structural formula and see. If not, there is a chance that you may go wrong. Look at this particular carbon atom over here. Okay, look at this carbon atom to which the halogen is connected to here over here. This carbon atom I'm talking about. This carbon atom, look at this. There is a bond over here. There's a bond over here. There's a bond over here. There's a bond over here, which makes this carbon atom to be sp3 hybridized, which makes it sp3 hybridized, which in turn is connected to carbon-carbon double bond over here. And carbon-carbon double bond in the sense, it should be sp2 hybridized, which is connected on sp3 carbon. sp3 carbon is connected on halogen. So obviously, if you have imagined that the answer is A, that is the first one, then you are very right. It is an allyl carbon. Very right. Very good. Let's move on to the next question. Let us see what is the second question says. In the dehydrohalogenation of ethyl chloride, the following changes occur. Okay, what is asked? Dehydrohalogenation of ethyl chloride is taking place, and what are the changes happening into it? What are your options given? Okay, sp2 carbon converts to sp3 carbon, sp2 carbon converts to sp carbon, sp3 carbon converts to sp carbon, and sp3 carbon converts to sp2 carbon. Now, what is dehydrohalogenation? You know, removal of one hydrogen and one halogen. And what is the reagent that you use over here? Alcoholic KOH. I said in organic chemistry, you need to write. If not, there is a chance that you will make mistakes. So let us write this reaction. Look into what has happened over here. Okay, look at the carbon atom over here. This carbon atom is sp3 hybridized carbon atom. What hybridized carbon atom? sp3 hybridized carbon. This is also sp3 hybridized carbon atom. Okay, when you are treating it with alcoholic KOH, you are losing an halogen atom from an alpha carbon. Okay, what is an alpha carbon? Try to recall. Alpha carbon is the one to which a functional group is connected to. The immediate next carbon atom is beta carbon. The hydrogens which are connected to beta carbon, okay, are called beta hydrogens. Fine. They are called beta hydrogens. 1 minute. They are called beta hydrogens. So in this reaction, beta hydrogen has been lost from this beta carbon, okay, and then halogen has been lost from here. So what are you getting? You are getting a carbon which is sp2 hybridized. From sp3 carbon, you are coming to sp2 carbon. Clear? So what is happening in this reaction? sp3 carbon is getting converted to sp2 carbon. Correct? So what should be your option? Your option should be, if you have imagined it is as D, then you are conceptually very right. It should be sp3 carbon getting converted to sp2 carbon. Fine. Let's move on to the next problem. What is the next problem? Okay. It says, okay, you have a mixture of PCl3 and PCl5 heated with ethyl alcohol. Total of 4 moles of ethyl chloride is formed. Okay. Mole ratio of PCl3 and PCl5 in the mixture is. Now read the question once again. They have asked you the ratio between PCl3 and PCl5. If you have imagined directly it is as 3:1, then obvious, you are going to go wrong, obviously. Wait what I said, write the reaction and then just check. So let's write the reaction first of all. Let's write the reaction. Okay, look what is happening over here. Okay, you have taken PCl5, you have treated it with ethyl alcohol. PCl5 with ethyl alcohol gives you ethyl chloride. How much PCl5 has been used over here? 1 mole has been used. What is the amount of product that you are getting? 1 mole of major product that you are getting. How much ethyl alcohol you have used? 1 mole of ethyl alcohol. But for us, interesting part is this. How much mole of PCl5 has been used? 1 mole has been used. Okay, let us move on to the next, reaction. Okay, wherein we are treating PCl3 with that of ethyl alcohol. How many moles have used? 3 moles of ethyl alcohol. How many moles of PCl3? 1 mole. How much of product has been formed? 3 moles. Had it been they had asked you the ratio between the products formed in this reaction, it would have been 1:3. But what they have asked, ratio between PCl3 and PCl5. PCl3 and PCl5. So look into this. You have used 1 mole of PCl5. You have used 1 mole of PCl3. So what should be your option? Your option should be PCl5 and PCl3 is in the ratio of 1:1. So option should be second one. If you had written directly as 3:1, you would go wrong. If you have written it as 1:1, then you are conceptually correct. Okay, let us move on to the next question. Which of the following is chiral? Which of the following is chiral? Let's recall our basic definition. What is chiral? A chiral molecule is one who does not have plane of symmetry. And what is a chiral carbon then? A chiral carbon is one which is connected to 4 different atoms or groups. Okay, a molecule who has more than 2 chiral carbon atoms need not be always chiral molecule. Remember, a chiral carbon is different. A chiral molecule is different. A chiral carbon, a molecule who has got only 1 chiral carbon can be chiral molecule. But a molecule with more than 2 chiral carbon atoms need not always be chiral. So let us look into our options that are given to us. Let us talk about 2,3 dibromobutane. Okay, what is taken here? You have carbon atom over here. Okay, yeah, let us look into the nomenclature part first of all. Look, 4 carbon atoms we have taken, 1, 2, 3, 4. On second and third position, you have a bromine atom. Let me give one important thing over here, people. One tip for your people. Wherever they mention the branching, you have to try to see at that particular point or that particular carbon atom. Here they have mentioned 2 and 3. So I'll look for the chirality at 2 and 3. Look at this particular carbon atom. Is it chiral? Let us see. What is the definition? A chiral carbon is one which is connected to 4 different atoms or groups. Look at this carbon. This carbon is connected to one side by CH3, another side by Br, another side by hydrogen, and this entire one group. So obviously this should be chiral. You might have come to a conclusion. Very right. What about this particular carbon? It is also chiral carbon. Why? Look at this. There is a Br atom over here. There's a hydrogen over here, and there is CH3 over here. So, and this is one entire group connected over here. So obviously this is also chiral. So if you come to a conclusion, this is our answer, then it's wrong. You can divide this molecule into 2 equal halves. Look at this. This half, okay, and this half are mirror images of each other. You try to fold and see. Try to fold on this particular thing and see. It is a non-chiral molecule, a chiral molecule. There's a plane of symmetry. There is a plane of symmetry over here. So this shouldn't be our option. This shouldn't be our option. So is our option C? Let us see. Okay, look at this particular option over here. You have this particular chiral carbon. Okay, what is the option? 3-bromopentane. Let us see. There are 5 carbon atoms. 1, 2, 3, 4, 5. Bromine atom is connected over here. Hydrogen atom is connected over here. Is it chiral carbon? Let us see. Our definition says a chiral carbon is one which is connected to 4 different atoms or groups. Look, there is a hydrogen atom over here. Okay. Br atom over here. Okay. This is ethyl group and this is also an ethyl group. Both are similar group. So this is not a chiral carbon. So this is also not our option. Let's go to the next one. 2-methyl butanol. Look at this. What has happened here? Okay. This carbon is connected to OH over here. Ethyl over here. This is ethyl group. This is your OH. This is your methyl and methyl. 2 similar groups are there. So this shouldn't be our chiral carbon. So this is also not our option. Let us look into the last. Obviously, that should be our answer, but let us verify it. Look into what has happened over here. This carbon is connected to OH on this side, COH over here, H over here, CH3 over here. Is it a chiral carbon? Of course, this is our chiral carbon, and this should be our answer. See, people, you have to always write immediately all the structures and verify whether it is a right or not, because every mark counts in your competitive exams. Fine. So what should be our answer? Our answer should be 2-hydroxypropanoic acid. That is nothing but, this structure, which is a chiral structure. So this is our answer. Let's move on to the next option. Okay. Which, of the molecules here given, undergoes nucleophilic substitution exclusively by SN1 mechanism? Fine. Which of these will undergo, reaction by SN1 mechanism? Ethyl chloride, isopropyl chloride, chlorobenzene, benzyl chloride. You have these 4 options with you all, people. Okay. Now don't forget one basic principle of SN1 mechanism. What is that? Reactivity in SN1 reaction depends upon the stability of carbocation. More stable carbocation always, participates SN1 reaction daringly. It says I can form carbocation, I'm stable, I can participate into SN1 mechanism. What about SN2? All those carbocations which cannot be stable, which do not want to be, which are not stable, will participate through SN2 mechanism. So here it is always, stable carbocation. So now let's see which is the stable carbocation. Imagine if our molecule is ethyl chloride. This ethyl chloride molecule, if the bond is broken over here, imagine exactly, and you get this particular carbon which is positively charged over here, which is positively charged. It is carbocation. This carbon, who is identified this carbon atom is primary carbon. Why? Primary carbon is one which is connected to only one carbon directly, and a positive charge is there. This is a primary carbocation. What carbocation? Primary carbocation. And do you think primary carbocations undergo SN1 mechanism? Difficult, not at all possible, not at all possible. So this shouldn't be our option, 100%. This shouldn't be our option. What about second one? Isopropyl chloride. Look at this, isopropyl chloride. I've written the structure over here, isopropyl chloride. If the bond is broken over here, a positive charge is developed on this particular carbon. I've shown it over here. What is this carbon? This carbon atom is a secondary carbon. Look, carbon which is connected to 2 other carbons is secondary, a positive charge is developed. So secondary carbocation. What is our arrangement sequence that we have learned in the chapter? Tertiary greater than secondary greater than primary. Can this be our option? Let us see. We have got 2 more, examples given here, 2 more options given to us. Of course, remember this: tertiary greater than secondary greater than primary, but decide after looking into this. Chlorobenzene. Let us talk about chlorobenzene. What is chlorobenzene? A chlorine atom is connected directly to benzene ring over here. This is sp2 hybridized carbon atom. Remember, don't forget there is a lone pair of electron on this particular chlorine atom. They undergo delocalization. You will have learned they undergo delocalization over here, and a partial double bond character is developed here. Partial double bond character. First of all, this bond cannot be broken easily. It cannot be broken easily because the delocalization takes place. And somehow imagine you have broken the bond. The positive charge will be developed over here. This is called phenyl cation. Very, very unstable carbocation. Why unstable carbocation? Because the positive charge over here, imagine this is the pi orbital of the carbon atom over here, sp2. There is an orbital over here, another sp2 orbital over here, which is present here, which actually is connected to a p orbital of chlorine atom. When this is broken, the positive charge is developed over here, which cannot enter into this. The positive charge is over here. This is the orbital. The positive charge cannot go into over here, and delocalization doesn't take place. So this carbon atom says, Baba, I am so unstable. How can I form? I will not form in this particular reaction. So this is not our option because it is an unstable carbocation. What about the next one? Benzyl. Benzyl is given. So in benzyl, if you see the bond will be broken over here, and a positive charge will be developed on this. If you look at this carbon, you may say, sir, this is a primary carbon alva, primary carbocation idu. So it should be unstable. So you may go for this particular option number 2. Wait, it's not like that. Look at this particular carbon atom over here. The positive charge which is developed on this particular carbon atom undergoes delocalization. Don't forget, this particular bond comes over here. A positive charge developed on ortho. This comes over here. A positive charge develops on the para position. From here, the delocalization takes place. Positive charge comes. This positive charge is delocalized very finely in this benzene ring, very finely, making this carbocation very, very, very stable. Stable than your secondary carbocation also. And therefore, option for this reaction, this particular question should be D1 and not your B1. Though it is secondary, though it is primary, benzyl carbocations are more stable than tertiary also. This is a generalized concept. People situationally changes also. When in general, benzylic are more stable than tertiary, which are more stable than secondary, which are more stable than primary. Okay, you all have learned one more kind of carbocation. What is that? Allylic. That allylic carbocation, based on situation, may come before secondary carbocation also. It depends which allylic carbocation you are talking about. Right now, this is not necessary in this particular question. Already we have answered benzyl chloride. So let us move on to our next option. Okay, next question. What is this? In the reaction, Z is, see, you have been asked to find out what this Z is. Fine. So now what I've told you, to your people in the beginning, organic chemistry needs lots of writing. Never go to the conclusion immediately. Okay, so let's write the reaction. I will divide this into three phases. Okay, our substrate molecule gives X, X gives Y, Y gives Z. Let me write the first reaction. What is given to your people? You might have understood. We have done this in the beginning also. Okay, this carbon atom is your alpha carbon. From this is beta carbon. From this carbon, you will be losing your hydrogen and you will be getting an alkene over here, alkene. Why? We have used a dehydrohalogenating agent, alcoholic KOH, strong dehydrohalogenating agent. So you got an alkene over here. Fine. So this is your first option. First X is your what? Alkene. What alkene is this? Propene. It is propene. Fine. Then let us treat this propene with HBr in presence of peroxide. Let's see what happens. Look what has happened. HBr. Okay. In presence of peroxide. Where you will have learned this. Last year you learned in hydrocarbons. This year also you were told about this in the preparation of haloalkanes, free radical halogenation mechanism. Remember that. Okay, HBr is added in presence of peroxide. Which effect is this? Anti-Markovnikov's rule. What anti-Markovnikov's rule says? During the addition of an unsymmetrical molecule to an unsymmetrical alkene, remember it is anti-Markovnikov against Markovnikov rule. The negative part of the adding molecule goes to that carbon which has a double bond and maximum number of hydrogen atoms. Markovnikov's is okay. In Markovnikov's, Br will go to this carbon atom, secondary carbon. But here, this is not just free radical halogenation. Okay, it is guided by peroxide also. Remember that peroxide also. Okay, fine. Fine. So Markovnikov's, it is anti-Markovnikov's rule. So what you will get? You will get this Br going to first, and you are getting, what is this? 1 bromopropane. 1 bromopropane. Okay, 1 bromopropane. So this is not a free radical mechanism. Okay, this is an addition reaction, but HBr undergoes free radical mechanism. Okay, normally HCl and HI undergo normal addition by Markovnikov's rule. HBr undergoes reaction by formation of free radicals because peroxide is over here. So you got 1 bromopropane. Fine. Okay, make this correction. Then Y is treated with NaI in acetone. NaI in acetone. So what is happening? What is this reaction? You will have learned this here. You have learned this reaction. What is this reaction? This is Finkelstein reaction where your Br is replaced by I. And what are you getting? You are getting iodopropane, 1 iodopropane. And what should be your option here? Obviously, it should be your first one. That is A. Fine. Let's move on to the, see, if you write the reaction in a sequential order, you will always reach to a correct answer. Remember that. Fine. Next is this. What is the question? Methyl alcohol is treated with Pi3, phosphorus triiodide. You are getting A. A is treated with KCN. You get B. And B on hydrolysis, you get C. Okay. Again, write the reactions and just see people what is going to happen. Look, the first equation I have written. What has happened over here? Your OH has been replaced by I, and what are you getting? You are getting methyl iodide. The first, the A that is formed is methyl iodide. Okay, simple substitution reaction. OH gets replaced by I. Fine. This is what you'll have learned in your text, the first chapter. Now what have I done? This A is treated with potassium cyanide in the medium of alcohol. What is happening? I is getting replaced by CN. Look, this is one of the most important cases in organic chemistry. Why do we use CN? Okay, whenever KCN is used, there is always an increase in one carbon atom in the chain. Okay, this is called ascent in series. What is it called? Ascent in series or ascending in homologous series. One of the best way by which you can increase one carbon atom in the given molecule. So what are you getting? You are getting methyl cyanide or ethane nitrile in IUPAC, you can call it. Now what? You are doing hydrolysis. Hydrolysis of cyanides. Where have you learned? Recall. It's in carboxylic acid. What is going to happen? If you hydrolyze this, okay, cyanide, you are going to end up into COOH. You're going to end up it into COH. That is carboxylic acid. So I need not tell you what should be our option. If you have imagined it as D, then you are very right. If you write the reactions, you will be always arriving to a correct answer. I'm saying this again and again. People, organic chemistry, don't take a risk. You have to write each and every step very properly. Fine. So now we have solved this particular problem successfully. Let's move on to the 8th problem. The reactivity of, okay, these molecules have been given to your people, follows the following order. Okay, reactivity of all these follows the following order has been given to you. So let's see what is the order. You are being given 4 options: ethyl chloride, ethyl bromide, ethyl iodide, ethyl iodide, ethyl bromide, ethyl chloride, and ethyl bromide, ethyl iodide, ethyl chloride, ethyl chloride, ethyl iodide, and ethyl bromide. Okay, you will have learned one thing in your periodic table last year. What was that? Okay, as you come from top to bottom in a periodic table, the size of the atom goes on increasing, mass goes on increasing. So if you imagine these 3, okay, fluorine, chlorine, bromine, iodine. This is not given to y'all people. So chlorine, bromine, iodine, look, the mass has increased, size has increased. So what should happen? Bonds length also should go on increase. How? You will have learned it, people. Imagine you have connected this carbon atom with a spring, okay, which is connected to a 1 gram ball, another with around 2 gram ball, another with around 10 gram ball. Which will get more stretched? The one with heavier mass. The same thing happens over here also. Iodine is heavier, so bond length will increase. Bond length should increase. Okay. Now they have asked you the reactivity, people. Reactivity in the sense what? Who will participate in the reaction much more faster? And what is the reaction? Breaking of old bonds and making of new bonds. So one whose bonds are broken faster will participate in the reaction faster. So the one whose bond should be longer should be broken faster. Okay. So remember one important thing here. Okay. Longer the bond, weaker the bond. Weaker the bond. Okay, less dissociation energy. And if less dissociation energy is used, better will be the living group because the bond will be broken faster and more will be the reactivity. That means the bond between carbon and Cl is smaller, carbon and Br is longer, carbon and iodine is longest. It will be broken faster than bromine, than chlorine. Okay, so if you arrange them in a general reactivity, general order, okay, if you put them, it is Ri greater than Rbr, greater than Rcl, greater than Rf. So what should be your option? Your option should be B1, obviously, because this bond length is bigger. So bond will be broken faster than this C2H5Br compared to that of C2H5Cl. Okay, fine. So this is our, remember this, what I have given: longer the bond, weaker the bond, less dissociation energy, better will be the living group, and more will be the reactivity. Remember. Okay, simply reactivity, okay, is a tendency of a molecule to participate in the reaction more faster. Remember that. Okay, so old bonds should be broken faster so that new bonds can be formed faster. Fine, let's move on to the next question. In the following reaction, the major product obtained is asked. Now you may say, Where have you come across this particular, reaction, sir? I mean, you will have learned this reaction. This is free radical halogenation. Don't forget. Okay, this is free radical halogenation. You learned it with chlorine. I've given it with bromine reaction. Okay, in free radical halogenation, remember one important, tip that I'm giving you all people: ease of abstraction of hydrogen is tertiary, greater than secondary, greater than primary. What that means, hydrogens which are connected to tertiary carbon are abstracted more than that of secondary, which is abstracted more than that of primary. Choice is in this order: tertiary, secondary, and primary, because tertiary free radicals are more stable than secondary, who are more stable than primary. Remember that, all of you. Now let us see which all kind of carbon atoms are there, which all kind of hydrogen atoms are there in this particular given molecule. Okay, look into this molecule. Okay, look into this molecule over here. Let me change the color. Look here, this particular carbon atom. Okay, this carbon atom. Look, this is a secondary carbon. Why it is connected to one bond over here, one bond over here? So there are two, and there are two hydrogen atoms over here. So this is a secondary, carbon, so secondary hydrogens. This is also secondary carbon, obviously connected to two other carbons. This is also secondary. This is also secondary. This carbon atom. Look at this carbon atom, people. This is our tertiary carbon. What carbon atom? Tertiary carbon. Okay, is there? Why is it tertiary? Look here. There is one bond over here, one bond over here, one bond over here. Carbon is connected to three other carbons directly. Now you may ask me, sir, hydrogen is there? Of course. This is hydrogen. There is a hydrogen over here. This is not an aromatic ring. There is a hydrogen over here. What should be the name of this compound? Okay, it should be 1-methyl cyclopentane. This hydrogen will be replaced. Tertiary hydrogen will be replaced. Remember that always. And so what should be our option out of these? Look at this. What is given to your people? Br is replaced from here. Br is here. Br over here. Br over here. So you know what is your option now. Your option is hydrogen is getting replaced from this particular position. So Br is replacing this hydrogen. So your option is obviously the first one. Next, we shall move on to the next question. This is very, very important question. Just see. One of the important, which I feel, in two separate experiments, equal quantities of alkyl halide CH4C9Cl, C4H9Cl, were treated at same temperature with equal volume of 0.1 molar and 0.2 molar solutions of NaOH respectively. In the two experiments, the times taken for the reaction of exactly 50% of alkyl halide were the same. The most likely structure of halide is, see what is given to you. Okay, the question appears to be very big, but let me tell you, it is one of the easiest questions. Look at this, what they have given. You are treating alkyl halide. What is that alkyl halide? C4H9Cl. Okay, you are treating it with 0.1 molar NaOH and 0.2 molar NaOH. And the 50% time taken for the reaction is same for both. How can that happen? Okay, this can happen only when the starting your reactant molecule, that is C4H9Cl, should not be dependent on what is the concentration of your NaOH. Understanding the mechanism? In the mechanism, what amount of or what concentration of NaOH is present, that doesn't matter in this reaction. And what are such reactions you will have come across? Okay, hydrolysis of tertiary, remember, tertiary carbons, is independent of your concentration. Tertiary carbocations, if they are involved, they are independent of the concentration of NaOH. Okay, what should be this reaction? This reaction should be your SN1 mechanism, SN1 reaction, where what is the reaction dependent upon? The reaction is dependent upon only the concentration of alkyl halide and not on the concentration of NaOH. So whether it is 0.1 molar or whether it is 0.2 molar, it doesn't matter at all. Okay, what matters is how much alkyl halide is used. So let us see who participates in your, who participates more in your, SN1 mechanism. In your SN1 mechanism, the sequence is tertiary greater than secondary greater than primary. We have already discussed. Look at this particular halogen. Where is it connected to? It is connected to a primary carbon. Now, why is this primary? Because it is directly connected to only one carbon. So this shouldn't be our option. What about this particular halogen atom? It is connected to this carbon, which in turn is connected to two other carbons directly. So this should be our secondary carbon. Okay, this can be our option, but let us wait till the end. Look at this. Okay, this halogen over here is connected because it is getting replaced. In SN1 reaction, we are replacing this. Okay, so this is connected to a primary carbon. This is a primary carbon. Don't forget, this is a primary carbon. Okay, so against the, see, this was our primary, this is our primary, so both are not our options. This can be an option. Let us think about after solving for this. What is this? Okay, look at this. I have put this particular molecule over here. Look, okay, this is Cl over here. The three carbon, the methyl groups are put over here. One methyl, another methyl over here. So this carbon atom is a tertiary carbon. What carbon atom is this? Okay, it is a tertiary carbon. So tertiary carbons are more stable than secondary carbon in SN1 reaction. And therefore, okay, the molecule who will, okay, the most likely structure of the halide is nothing but our third one, because it is tertiary. Fine, tertiary. These all are isomers of this particular. So you should find, so that's why I said you should write the structures for all the things and just see which one is stable for this particular, okay, kind of reaction. So option is D. Fine. Let's move on to the next. Look, this is also one of the beautiful questions. You have been given ethyl bromide is treated with alcoholic KOH, you get product 2, and ethyl bromide is treated with aqueous KOH, you get product 1. The correct statement is product 1. First option, product 1 is obtained by elimination reaction. Product 2 is obtained by the substitution reaction. The molecular formula of product 1 is C2H4, while that the formula of the product 2 is C2H6. The product 1 is the isomer of dimethyl ether, and product 2 is the dehydrated compound of product 1. So what are these options? Let us talk about. So you have to see one by one all of these. Let me write the reaction for product 1 and see what is happening in this reaction. Look, what is the product that we are going to get? Ethyl bromide is treated with aqueous KOH. What is aqueous KOH meant for? Nucleophilic substitution reaction. Br is getting replaced by OH, so you are getting a substituted product. Okay, so product 1 should be a substituted product. And what is given over here? Elimination reaction. So option 1 is wrong. What about second one? Okay, what about the second? The product 2 is obtained by substitution reaction. Let us see. Write the reaction quickly. What should happen? Ethyl bromide is treated with alcoholic KOH. You are getting C2H4. Okay, alcoholic KOH is meant for nucleophilic substitution reaction. No, it is meant for dehydrohalogenation, elimination reaction. Br is replaced from alpha carbon. Hydrogen is removed from Br is removed from alpha. Hydrogen is removed from Br. This one carbon as beta carbon. So you are going to get C2H4, an eliminated product. What is given over here? A substitution reaction. But what are we getting? Elimination reaction. So obviously option 2 also is right. Let us look into our third one. The molecular formula product 1 is C2H4. Is it C2H4? No. If I sum up, it should become C2H6OY, 2 carbon atom, 5 plus 1, 6 hydrogen and 1 oxygen. It should be C2H4. Okay, what about this one? What about the second part? Product 2 is C2H6O. Is it? No, it is C2H4. So this is not our option. Obviously, the fourth one remains. Let us see. Product 1 is the isomer of dimethyl ether. What is product 1? Ethyl alcohol. Is it an isomer of dimethyl ether? Okay, of course, you have learned it last year, Okay, alcohols are isomers of ethers. Look, formula 2 carbon atoms. Okay, 3 plus 3, 6 hydrogen atoms and 1 oxygen. Yes, matches. What about this? Ethyl alcohol, dehydration, C2H4. Correct. C2H4 is a dehydrated product. Okay. Product 2 is a dehydrated product of 1. Very right. So if you have come to a conclusion that the D is your option, then conceptually you are very, very correct. Let's go to the next option. Look. Identify X and Y in the following sequence. What is given? C2H5Br. Okay, in presence of X gives you a product. Which on treatment with Y gives you C3H7NH2. Okay, options are given here. KCN and lithium aluminum hydride, KCN and H3O plus, CH3Cl, aluminum chloride and HCl and AgCN and HNO. Now the option, you have to come to a correct, conclusion. So you have to write the reaction and see. I'll write the first reaction. But before going to reaction, look the difference between the two. The ending material has one carbon atom extra than that of the first. First has 2 carbon, the second one has, the product has 3 carbon atoms. So there has been an increase in 1 carbon atom. And before, few questions back, I told you what is the best method to increase a carbon atom, 1 carbon atom. You can double it up also, but that's Wood's reaction. Okay, but here you want only 1 carbon atom, so it should be KCN. 100% sure, there is no other option. Okay, look, ethyl bromide, when treated with KCN, you are getting ethyl cyanide. 1 carbon atom increased over here, what actually we want over here. And the product, intermediate product that is formed is this ethyl cyanide with the help of KCN. So option C and D are out of question. It can be B or it can be A. Let us see what is the right option. Now you have to convert this cyanide into your amine. What are you going to do? No hydrolysis. If you do hydrolysis, you will get an acid. Okay, you have to reduce it. And the reducing agent that you have been introduced to your people in your textbook, one of the reducing agent is lithium aluminum hydride. Let us see this happens or not. Of course it happens. Okay, 2 hydrogens are added to this particular high carbon atom, 2 towards the nitrogen atom, and what are you going to get? You are going to get propylamine, the expected product. So why should be your lithium aluminum hydride? If some other reagent was used, yeah, of course, for this reduction you can use hydrogen in presence of nickel also. Okay, you can use platinum also in presence of nickel, or sodium amalgam can be used in presence of ethyl alcohol. Okay, you can be, this is also important, you should remember people, reduction of this is possible in presence of sodium alcohol or sodium and alcohol. This reaction will be called as a Mende's reaction in such cases. Fine. So what should be option? I did not tell you now, you have understood it. It should be KCN and LiAlH4, lithium aluminum hydride. So option should be obviously, A. Fine. The next question. In the following reaction, compound C is, look. Now you may look at this, question that is asked. C7H8 treated with chlorine in presence of heat. Okay. A is formed, which is treated with Br and Fe in presence of Fe. Okay. You will get B, and B on treatment with zinc and hydrochloric acid, you're going to get C. Okay. You're going to get C. So you will think, what is the C7H8? Very easy. Look at this option. Toluene, 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 toluene. So it should be toluene. Okay, if not, just imagine you are having C6H6, add CH2 to that, CH2, what you are going to get? C7H8. And okay, getting my point. The higher member of this one, that is toluene. Fine, toluene. So let's move on to writing this reaction one by one. Okay, look into. Fine. Let me write the first reaction for your people. I said writing reaction is very important here. You are treating toluene with chlorine at high temperature. How is that this chlorine atom went to the side chain? Why didn't it come into the benzene ring? Remember, at higher temperature, halogens will not add across the double bond. They will always try to replace the hydrogen atoms. Okay, so hydrogens from the side chain are getting replaced. Remember that. So hydrogens got replaced from here. This is very important. Remember that. Okay, at higher temperature, halogens will prefer not to add across the double bond. They will substitute. So here the substitution took place. So what is this? This is called benzotrichloride, where all the hydrogen atoms from the toluene have been from the methyl group of toluene have been replaced. So you got CCl3. Fine. Now what are you going to do? You are going to treat it with bromine in presence of iron. Remember, it is an halogen carrier catalyst. So where should be the halogen going? That halogen in presence of iron should attack on benzene ring. Okay. Why did that bromine go on meta position then? Why didn't it go on ortho positions? Remember, people, okay, this is CCl3 connected to carbon. Cl is an electron withdrawing group. There are 3,3Cl, carbon is getting connected to 3,3Cl. Cl over here, Cl over here, Cl over here. Fine. All 3 are electron withdrawing group. So they reduce the electron density on ortho as well as para position. They will reduce. Okay. I'll write and show it to you over here. What happens? Okay. They will reduce the electron density on ortho and position, para position. So only position that remains for attack is, meta position. And who is the attacking agent? Bromonium ion. Okay, so what are you going to get? You are going to get bromine on meta position. Fine. So that is our option B. Our product B. Fine. So now this product B is getting reduced in presence of zinc and hydrochloric acid. All the Cl will go and H will come on that position. Okay, H will come on that position. Cl will be replaced by hydrogen. So your product is, what should be your product? It should be metabromotoluene. Metabromotoluene. Fine. Okay, let's move on to the next. Students, I think the time allotted for me is almost over. I was aiming for another 7 questions, but fine. Okay, we will end up over here. Whatever questions that I've dealt to you all people, dealt today for you all people, I think you all are well versed with it now. Okay, hope you will do better in your CT exam. Hope for the best. God bless all of you. Try for the best and get your best out of it. Put your efforts, okay, and do your best. Thank you. Thank you, everyone.